Today we will be talking about transformation. So on Thursday, we looked at this discovery activity, linear transformations. So here is what your graph should look like. You should have your graph done. If you don't, you'll have to come back to it or do it as we are going through this. But the most important part of this is going through the discussion part. And so let's look at the question. What do you notice about the graphs?
They're all positive.
They all go through the origin.
Okay, I'll go through the origin and positive. Okay. They're linear, go through the origin, positive slope. How does changing the slope affect the graph? So raise your hand if you want to tell me how changing the slope affects the graph. Emmy?
Turn on the slope can make it positive or negative, and the slope can be steeper, like flatter.
Mm-hmm. Steeper or flatter? Yep. So just changing the slope, like these, it wasn't changed positive or negative. They just went, there was a 2, a 1, a half, and a 4. So the slope changes the steepness of the line. And then we need to list the graphs in order from most steep to least steep. Will somebody raise your hand if you want to tell me the order for most steep to least steep? Carter.
I'm going to go by colors.
Okay.
Green.
Okay, so I'll put like 1.
Pink.
Pink.
Blue.
Okay.
Purple.
Okay. So we could write it like this. I think some of y'all wrote it as like A, B, C, or D. So this would be D, A, B, C. So if we just look at the slope, like this slope would be 4. This slope is 2. This slope is 1, right? And then half. Without even graphing them, how would you know which one's the steepest? The 4, so it's 4, 2, 1, half. So it goes from greatest to least on the numbers. Okay, so the larger the number, the steeper the graph. And we'll ignore negatives at this point. We're not going to think about negatives all. We're only thinking about steepness. So a -5 would be steeper than these two. We're only looking at the number. Okay, let's go on to number 5. Graph the following equations in different colors. Okay, so I graphed them. Okay, so we need to look at, let's look at the green and pink. That is 3x and -3x. What do you notice about 3x versus -3x? They reflect over the y-axis, yeah. This is our y-axis. If I were to reflect, it would go up over there. And then y equals x and y equals -x. This is also the same thing. You reflect it over that axis. So what do you notice what happens if your slope is negative?
It goes from left to right and it falls instead of rising.
Mm-hmm. Yep. So it reflects over the y-axis. If it's positive, it rises from left to right. If it's negative, it falls from left to right. So the negative does not change steepness. The number of your slope, the whatever that rational number is, that is your slope, that's what changes steepness. The negative only changes how it looks as far as rise or fall. Okay, let's go to the next page. Y'all ready? You'll need a few more seconds. Okay. Okay, here are the lines. So a tip on graphing these lines, which you're going to have to use, you're going to have to be really precise with your lines on that stained glass project because you want it to look good. A tip would be do your dots and then either go all above or all below the dots. So on mine, I went all below. So I lined up my ruler on those dots, but a little below. So that way, whenever I do my line, it goes directly through the dots. So we have these equations, y equals 2x, 2x plus 6, 2x minus 3, 2x minus 5. So raise your hand if you can tell me, what do you notice about the graphs? What's something that you see?
They don't have like
So
They're parallel.
they're parallel. Okay, good. Carter, what'd you say?
they all have a light.
They all have a y-intercept. So this one, the y-intercept is 6. Then we have 0, -3, -5. Okay. So they're parallel. Parallel lines have the same slope. The y-intercept is different, though. So see how they all have that our slope ilm is 2? So if your slope ilm is 2, then your lines will be parallel. They will never touch. The lines never touch because they're parallel. Now think about, how does changing the y-intercept affect the graph? So raise your hand if you can tell me what you thought.
It moves the line up and down the line.
It what?
It moves the line up and down.
Moves the line. What's a, think back to your 8th grade math, whenever y'all did transformations with like shapes, like squares or circles. If it was changing the y-intercept or changing the location, what is that called? What kind of transformation is just moving it? Do you remember?
Transportation.
No.
Transportation.
Translation. Do y'all remember translation? No?
To be honest, I really was too worried about getting in trouble in this class.
So the lines are translated up or down the y-axis according to, did I spell according?
Yes.
I think it's missing something, but I'm not sure. According to the y-intercept. Is that right?
Yeah, that's right.
Okay, it just looks weird. It looks like it should have 2 R's or 2 D's or something. I don't know. I'm a math teacher. So the lines are translated up or down. We'll also use the word shift. We shift it up or shift it down, shift it left, shift it right. Okay, so let's look at the part 10. Y'all ready? Wow. Okay, describe the transformations from the graph of f of x to g of x. So without even graphing, let's look and see what is different about the equation and how does that affect the graph. So for our f of x equals x, this is called your linear parent function. Do y'all remember learning that? It's your linear parent function. Let's write that over here. Linear parent function. All the other linear functions come from the linear parent function. For the linear parent function, it goes through the origin. And it's also a positive slope. Slope equals 1. So it's the most basic linear function. So from this to this one, let's see what was changed about it. Let's look at the slope first. Slope here is 1, and the slope here is 2. So to go from this one to this one, what is going to be the change in the graph? How is it going to look different from this one?
Oh, it's going to be steeper.
Steeper, okay. So g of x is steeper. Okay. And then the other part of the graph, or of the function, is your y-intercept, the b. The b on this one would be 0, and the b here would be -3. So changing the y-intercept, what does that do to the graph? Yep. So g of x is shifted or translated down how many units? 3 units. Okay, part B. F of x equals x. G of x equals -x plus 2. So let's look at our slope first. What's the slope on f of x? What's the slope on g of x? Okay, so how does that change your graph?
It goes from positive slope to negative.
Yes. Oh, I forgot to put -x. G of x is a negative slope, so it falls, right?
Yeah.
G of x falls from left to right. So it's a reflection. So I can put over here reflection, y-axis. And then the other change to the equation would be your y-intercept. So this was 0 and this one's 2. So how does that change the graph?
Translated to
G of x is translated up 2 units. We could also write shifted, mean the same thing. Okay, now do C and D. So pause the video, and I want you to do C and D. So you should be finished with it now. So let's see how you did. So for C, G of x is steeper than f of x. And g of x is translated 5 units down from f of x. Because you're at 2, and then you go down to -3, making that 5. And then D, g of x is less steep, and there's a reflection. It falls from left to right. And then it is translated 6 units up.
Is it okay if we didn't put the n equals 1 and the b equals -?
Yes, that's fine if you didn't put that. Okay, so now we just need to summarize on our digital interactive notebook. So let's look at that. We're on slide 17. So changes in direction. F of x equals x goes to, if we're changing the direction, we're talking about a reflection. So then we would say, I'm going to say g of x equals f of -x. And then right down here, reflect across the y-axis. Anytime you see that it's now f of a -x, that means that you're plugging in a -x for x. Whenever you do that, that causes a reflection across the y-axis. Okay, changes in slope. So I'm going to do g of x equals let's say 3 times f of x. Or it could be g of x equals, you can also change it if you do f of 3x. Both of these will cause a change in the slope. The line will be 3 times steeper. Just because I used a 3. If I used a half, it would be half the steepness, meaning less steep. And then the changes in the y-intercept will be f of x, let's say -6. Or it could be g of x equals f of x minus 6. It'll give you different lines. But this will change your y-intercept. Translate the line down 6 units. So these are the type of transformations that happen with linear functions. So now we just need to draw this. Draw some lines on here that show a reflection, that show a change in slope, and shows a change in the y-intercept. I'm going to zoom in on that other page. Maybe. There we go. Okay, so the first one was The slope, did we make it 3 times? Okay, so get a line and make it, let's say a 3x. I'm going to make the color blue. And it's still going to go through the origin, so we'll start at the origin. And then it's going to, let's see if I can, it did not change it for me. Blue and then thicker. Trying to click on it. There we go. And then it's going to go up 3/1. There we go. So you'll start at the origin, go up 3/1, up 3/1. And the ends need to have arrows. So make sure you put those arrows on there. So that, was that the one that we were doing, or were we doing the reflect? Y'all tell me, what did I can't see over here.
That was just a reflect.
Oh, okay. So the next one was the 3x. So I need to move this one down. Okay. So then the other one, so I'm going to copy and paste this. Nope, wrong thing. So that was a reflection. Whoops. It is tricky doing this. Okay. So I'm going to draw another line, and it needs to go like that. The reflection instead. So it goes through the origin, and it's the slope of -1. Okay, did y'all get those 2 graphs? Do y'all need more time? Okay, and then the last one was changing the y-intercept to down 3. I'm just going to copy and paste this line so that I can use that. Down 6, right? 1, 2, 3, 4, 5, 6. And then the slope should stay the same. Up 1/1. One, 2, 3, 4, 5, 6. There we go. Up 1/1, up 1/1. Down 1, 2, 3, 4, 5, 6, and then rise over run. 1. Okay. It can be tricky. Okay, make sure that you have your entire digital interactive notebook completed by Thursday. That's when it'll be due. Make sure you complete this reflection, and this is a reflection over the units. So make sure you think back to what all you learned in this unit, and you should be able to finish that.